Big data is data that's too large to process using conventional methods. The search engines were the first to come across this problem because of the amount of data they were collecting from their search crawl. But today, with science, mobile phones, sensors, social networks, we're seeing petabytes of data created daily. Google solved this problem by creating something called MapReduce, and that's now a popular open source project in the form of Hadoop created at Yahoo. We're seeing there's an ecosystem of big data tools growing up, and it comprises the following layers of storage, MapReduce and Query, SMAQ or SMAQ. This ecosystem is at the heart of big data processing tools. SMAQ systems are bringing big data processing to a broad audience. So let's take a look at the components of SMAQ. First, MapReduce. So MapReduce is the powerhouse behind most of today's big data processing systems. It enables you to take a problem and divide it across a large number of servers. The predominant implementation is Hadoop, which originated at Yahoo and is now an Apache project. In fact, it's grown up into a large ecosystem itself and now comprises a complete SMAQ stack. So now onto storage. So MapReduce requires storage from which to get the data to process and a place to put the results. One of the key things for this storage is that it's distributed so it can underpin the MapReduce computation. Another interesting aspect of it is that it doesn't have to be relational. In fact, MapReduce data is unstructured or schemaless. The storage for Hadoop is the Hadoop distributed file system. And as its name suggests, it's a very simple layer that enables you to put files in and get files out. It doesn't really support random access or indexing. So what we're seeing is that database layers are being placed on top of this to give richer functionality. These are products like HBase or Cassandra. Also, we're seeing search layers being placed on top of this data. Tools like Solr provide indexing and quick access to data inside the file system. Now let's look at the final stage of the SMAQ stack, Query. So you can think of MapReduce and storage as a bit like the CPU and disk of a computer. You could program in low-level assembly language to achieve what you want to do, but it's kind of laborious. So there are layers on top, programming languages and tools that make the job easier, that make people more productive, and they allow people with different skills to interact with the machine. This is what I'm calling the query layer in the SMAQ stack. Languages that enable developers and analysts to run MapReduce jobs without the laborious and labor-intensive job of writing lines and lines of Java code. There are some key projects that are part of this query layer. One of these is Pig, which again is part of Hadoop. It provides a higher-level language for expressing the computation of a MapReduce stack, taking 20 lines of Java down to 4 or 5 lines of Pig Latin. So there's also Hive, which is a complete data warehousing solution built around the Hadoop stack. This came out of Facebook, where they have hundreds of people each day accessing data and analytics. And Hive presents an easy-to-use interface where people can write queries against the data using SQL. Now, not quite in the same category is an API called Cascading. Now, Cascading is simply a layer above the Hadoop API that makes it a lot more usable for developers. It provides building blocks for orchestrating MapReduce jobs. So Cascading is very fertile ground for people who want to write their own in-house tools on top of Hadoop that make data accessible to their own users. So these layers, storage, MapReduce, query, the SMAQ stack, they're at the heart of modern big data processing systems. Because they're open source, because they run on commodity hardware, they're available to more people than could have done these things before. Particularly at the edges of organizations, for small teams, solo teams, experimental investigation into data is now economic. In the same way that the LAMP stack of Linux, Apache, MySQL, and Perl set off the Web 2.0 revolution, the SMAQ stack bringing commodity data processing is going to ignite a revolution of data-driven products and services.